1956 Chevrolet Radiator. Our cores are built in San Bernardino, California, where we will start by showing the core as it is being built step by step. The header plates are cut to size from sheets of brass. The tube holes are stamped into each header. We will use 5/8 inch tubes for this core, and the tubes will be on 7/16 inch centers. The headers are pressed with a drop seam edge to allow for a better tank to core bond. The tubes are then cut to size. We use dimpled tubes to increase the cooling ability of our cores. These dimples stir the coolant as it flows through the core and adds as much as 20% more cooling ability to a standard core of equal size. The fin machine takes flat copper from a spool and bends it to form the cooling fins. It also cuts in louvers to allow the fins to pull heat from the core. The technician uses a special jig to stack the tubes and fins, one on top of the other until the required width. Care is given to make sure that the core is flat and has good appearance. This is a close-up of the fins. You can see the louvers, and we use 14 fins per inch in our cores for optimal performance. The header plates are pressed onto the cores. A special tool is used to open all of the tubes and make them fit tight to the header plate. The core is measured and rechecked to make sure of the correct height. Now the core is ready to go into the oven to be baked. First, the core is acid washed to clean any oils from the core that would contaminate the solder joints. Then it is air dried and into the oven, baked at 660 degrees for about 10 minutes. This will allow the solder from the coated tubes to adhere to the fins. After baking the core, the header plates are ready to be attached. First, the dip in the flux pot. The header is then dipped into the solder tank. The technician holds the header under the solder until all the tubes have had a chance for the solder to flow around each tube. The header plate is sprayed off with air to remove any solder inside the tubes, and the excess is brushed away. The other header plate is dipped, repeating the process, and the core is now ready for testing. Back at the shop, our technician will uncrate the core and measure it for its accuracy. He also checks to make sure that the tanks will fit correctly. We tin down the inside and outside of the tanks. This tinning process gives the brass tank a coat of solder and flux to make a pure surface to bond with the core. We tin the inside of the tanks to allow for a double bond of solder, giving our radiators the strongest tank to header seam in the industry. The header plate is tinned down to remove any oxidation that may have occurred during shipping. With both tanks and core cleaned and tinned, we are ready for assembly. The tank is fitted to the core and tack welded. The first pass allows for the solder to flow into the core to weld the inside of the tank. We use a high temperature to get the solder to flow. The second pass fills the drop seam on the outside of the core and adds a good cosmetic appearance. This is an example of our drop seam and the double bond that makes our radiators last longer. The second tank is installed and soldered along with the fill neck and outlets. The brackets and the straps are the last to be attached. The finished radiator is now ready to be pressure tested. We test to 18 pounds of pressure to make sure your radiator will not leak. The radiator is rinsed off and set aside to dry. We give our radiators 2 coats of paint to prevent corrosion of the copper core. The tank and side straps are painted with a hard coat of black to prevent fingerprints and scratching. Our radiator is finished and ready to install.